Good morning, students. Today we are going to start a new topic in chemistry O levels, that is energy changes. So concentrate yourself. We are going to start now. Energy changes in chemical reactions. All chemicals have energy stored in the form of the chemical energy. During a chemical reaction, changes to the stored chemical energy occurs. The chemical energy is changed into other forms of the energy such as heat energy, light energy, and electrical energy. Most energy changes that occur during a chemical reaction involves heat energy. Unit of the energy is the kilojoule, represented by kJ. Now we are going to read the endothermic reactions. A reaction that takes in heat from the surroundings is called an endothermic reaction. Endo stands for inside, therm stands for heat. Whenever a chemical reactions become hotter or colder as they proceed. Reactions give out or absorb heat for making or breaking of the chemical bonds. Breaking chemical bonds, taking in heat from the surroundings. And this is the general diagram of endothermic reactions. Here is the system that contains reactants and products. Heat will be taken in from the surrounding. That's why the temperature of the surrounding will fall. The temperature of the surroundings decreases. The reaction container becomes cold. The energy contents of the products is higher than the energy contents of the reactants because heat is taken in from the surrounding to the system. That's why the energy content of the products will be higher than that of the energy content of the reactants. Here is the energy level diagram of endothermic reactions. Products will be put above, reactants will be put down. This arrow will be upward because heat energy is absorbed from the surroundings. Delta H will be positive and this arrow will be upward, energy will be written here. So this is the general energy level diagram for endothermic reactions. The surroundings consist of the reaction container, the laboratory room, and anything else other than the reactants and the products. So in short, actually other than the reactants and product, everything is called surrounding. Delta H represents the heat of the reaction, that is the heat change that occurs during a reaction. Delta H is equal to the difference between the energy content of the products and that of the reactants. Delta H is given a positive sign for endothermic reactions. Here is a general figure for the room temperatures for exothermic and endothermic reactions. In exothermic reactions, room temperature will be rises. And in endothermic reactions, the room temperature will fall because in endothermic reactions, heat is taking in, and in exothermic reactions, heat is given out. Example is here. Formation of the carbon disulfide is an endothermic reaction, and the equation is given. 100 kilojoule is required to form 1 mole of the carbon disulfide from 1 mole of the carbon and 2 moles of the sulfur. So here is the equation. 1 mole carbon disulfide has a higher energy content than 1 mole of the carbon and 2 moles of the sulfur because heat is taking in from the surrounding into the system. Here is the energy level diagram for this reaction. Products will be put above, reactants will be put down, this arrow will be upward, delta H is plus 100 kilojoule per mole, that is given in the reaction, heat is absorbed from the surrounding. All these things should be written in the paper. This arrow will be upward, energy will be written here. Other examples of the endothermic reactions are, first example is thermal decomposition of the carbonate salts. Heat energy is required to decompose carbonate salts. An example is here, that is calcium carbonate forms calcium oxide and carbon dioxide. Calcium carbonate forms copper carbonate forms copper oxide and carbon dioxide. Thermal decomposition of the nitrate salts. Heat energy is required to decompose nitrate salts. Lead nitrate is decomposed to lead oxide, nitrogen dioxide, and oxygen. Decomposition of the magnesium nitrate forms magnesium oxide, nitrogen dioxide, and oxygen. Next example of the endothermic reaction is solution of the hydrated salts in water. So, anhydrous forms the hydrated salts. Dissolving crystals of the hydrated copper sulfate in water is an endothermic reaction. Next example is of solution of the ammonium or potassium salts in water. Dissolving crystals of the potassium or ammonium salts in water requires heat energy. For example, potassium nitrate is dissolving in water, requires energy to dissolve, forms potassium nitrate aqueous solution. Dissolving ammonium nitrate in water requires energy, forms ammonium nitrate aqueous solution. Ammonium chloride to dissolve in water requires energy, forms ammonium chloride aqueous solution. Next example of the endothermic reaction is atomization. Dissociation of the chlorine molecule into gaseous atoms. Equation is here, Cl2 is converting into atoms. Next example is of photosynthesis in the endothermic reactions. Plants are able to convert simple compounds, carbon dioxide and water, into sugar. They do this by converting the energy of the sunlight into the energy of the chemical bonds in the sugar molecule. The reaction is called photosynthesis, and here is the equation: 6CO2 plus 6H2O in the presence of the sunlight forms glucose and oxygen. Next example in the topic of the endothermic reaction is dissolving. Many salts dissolve in water exothermically, some dissolves endothermically. Ammonium chloride and potassium nitrate dissolve endothermically. Many compounds decompose when they are heated. If the products recombine on cooling, then the reaction is described as thermal dissociation. This is the definition of the thermal dissociation, very important definition. Many compounds decompose when they are heated. If the products recombine on cooling, then the reaction is described as thermal dissociation. And students, at the end, we are going to read some very important definitions in this topic. These are frequently come in the paper. The first definition is heat of formation. The heat liberated or absorbed when 1 mole of a substance is formed from its constituent elements. Next is heat of combustion. The heat liberated when 1 mole of the substance is completely burned in excess oxygen. Next definition is of heat of neutralization. The heat is liberated when 1 mole of the hydrogen ions H plus react with 1 mole of the hydroxide ion OH negative. And the last definition is heat of reaction is the heat taken in when a reaction occurs between the number of the moles of the reactants shown in the equation. So this was the topic, students. Important topic, tricky topic, technical topic. You have to practice this again and again by writing at home. This is the time you can practice a lot, because in papers we do not have much time to think about, to balance the equations, to think the equations what will be. So this is the time you can practice yourself. So read this lecture again and make your notes. Thank you so much, students.